Hello everybody, this is Politicus Magnus, and I've decided to start this channel because pretty much everybody I know has told me to start a political channel, and haven't done this before, but I figured I'd give it a go since everybody told me to do it. While I do plan to mainly talk about politics on this channel, I hope to do so from a hopefully more intellectual perspective, and I guess what that means is I'm a scientist. I generally look at things from a scientific perspective, and that's what I'm going to try to bring to this channel. So the name of this first episode is Complexity and Tyranny. I had been debating with somebody who had suggested that capitalism in particular and kind of maybe democracy in general just turns into a zero-sum game. And I disagree with that. And so this first episode is about why that is. And I'm going to get into something called Complex Adaptive Systems Theory. For this episode, I'm not going to get into great detail about Complex Adaptive Systems Theory. I assume that you can go and Wikipedia it, which is a good place to start. I'd also recommend Frontiers of Complexity and The Origins of Order as good books, but you'd want to start with Frontiers of Complexity. That's a primer. Origins of Order you probably have to read about 10 times before, well, if you even get it after that, it's almost impossible. Even the experts, even the author, Stuart Kaufman, doesn't quite understand what he's done. And it may be a fair bet to say that it's possible that nobody fully understands the perfect details of complex adaptive systems. And this is because complex adaptive systems are almost, they're predictable, but they're not predictable. It's hard to articulate without, I mean, it's a mathematical theory. The closest I think most, I guess, lay people probably have gotten to that is Jurassic Park with the water on the hand and all of that. Chaos theory. And so complex systems theory is a subset of chaos theory, and specifically within complexity theory there is the subset of adaptive systems, which is to say they're complex systems, which is instead of randomness, they have chaos. And the difference between randomness and chaos is not generally important in math, unless it is important. And so that is the difference. It's different from normal statistical sets mathematically because it is deterministic, whereas you're not using, let's say, a random number generator. You can use that in place of chaos, but in real systems, that's not the case. So the question right now is capitalism in our society as we sort of have it, I mean, it could be better and so forth, but is capitalism and sort of the kind of democracy that we have, in general in the West, is that a zero-sum game? Is it to say that there are perfect winners and losers? And so mathematically speaking, of course, it's not a zero-sum game because the mathematics of that just doesn't really add up. It's deterministic, but you can't really predict the outcome. And also agents in a large, what's called a fitness landscape, they'll win and lose, but it's a gradation, so you can win some and lose some, and that's generally the case. But it's not zero-sum because there can be, two agents in a field that are, say, competing against one another can both lose, of course. So that's not zero-sum. And zero-sum means that one loses and the other wins. And if one wins, the other loses. And it's sort of it's a very socialist idea, actually, I think, because this is the idea that, if Elon Musk has however many billions of dollars that he has, that means that somehow that takes away from me, where in fact, the more capitalist-minded, the libertarian types, and even, of course, classical liberals in general, are going to argue that, Elon Musk having all of this money is actually a good thing for me. And I would also argue that because he's building friggin' spaceships and stuff, which maybe one day I can ride around in space for my 60th birthday or something like that. Who knows? And you know, I could be driving an electric car. So it is good for me, I think. And I don't see that as a zero sum. But then the question becomes, you know, what does it mean mathematically as well? Because the way we model these things, including the economy, including, you know, all these sorts of things. And so that's the thing about complex systems in general, is that predicting the outcome of any interaction, now let's say an agentic system is what it's called, a system with agents that act under usually specific rules. That's sort of how cellular automata work at the most simple level. And so we study very simple systems like cellular automata to try to understand how to model much more complex systems that don't necessarily follow hard, fast rules like the automata can be programmed to do in a computer. But what it ends up meaning is that for the first thing is you can't really predict, you really can't predict who's going to win any sort of interaction. You can't really predict the sets of interactions that may be possible, and all of that sort of stuff. And even after a few iterations of the game, maybe not a few, but you know, some small number relative to, you know, large timescales, it's already become unpredictable because of the chaotic element. So whereas chaotic systems diverge very rapidly, complex systems, and in particular complex adaptive systems, because they tend to stay within the same sort of range, which are called local optima and things like that. So it's very complicated mathematical stuff, but it is very important. And you know, I've noticed, for example, more recently, you know, we're having this whole debate over hurricane maps and all this stuff. It's more important for other things as well. And now, I guess, politically, because they're politicizing the weather. Of course, climate is highly politicized now, and how we study it and everything else. People should understand complexity theory more, because this is how the science in climate science is done. This is how weather modeling is done. Weather's more chaotic system, closer to a chaotic system, but there's other things. So anyways, getting into it, so the person was arguing that it's a zero-sum game. It's not a zero-sum game, and so that's what I want to get into. Sorry for the long introduction. You know, I wanted to do sort of a prelude, because what I'm discussing in this first episode is very strange stuff that most people haven't really had much contact with, like I said, other than watching Jurassic Park or something like that, and be like, oh, chaos theory. So yeah, to get right into it, and the implications, I think, in this case for totalitarianism, and why political systems that don't utilize distributed decision-making, as it were, by the agents in the system, in the form of what's called a fitness landscape, in the form of a competitive, ordered system of rules, such as a capitalist marketplace, then it is inevitable that it will degenerate into a totalitarian state. Because when you centralize control, you basically end up with the system breaking down. There are systems that you cannot centralize. And if you try to, you're going to break the system. Agents within a complex adaptive system are never playing a zero-sum game, at least in the infinite iterative limit. Rather, self-organized emergent behavior results in a mixed game far more complex by orders of magnitude than a prisoner's dilemma game, which would be zero-sum. Self-organization produces macro or meta behavior, which emerges to form a crystallized order, which is near the local optimum for the system and semi-critical, while being locally stable, and which is termed emergent behavior. This is how capitalist markets work. The units in the market, buyers and sellers, need only communicate price in order to create the market, and each unit or agent or automaton in the system is self-serving and only interested in gaining from exchange, which is a simplifying parameter in most modeled systems. The exchanges by self-sufficient, self-serving, and myopic agents in a market create the market itself. And that market then facilitates the exchange economy with individual agents only looking to profit from exchange in a highly complex and recursive way. As we see in markets, and also, for example, in biological evolution, with such semi-critical and metastable orders around such local optima in the fitness landscape is a constant series of coalescence around a metastable equilibrium, or sometimes more chaotically around multiple equilibria in the multidimensional fitness landscape, leading to a natural boom-bust cycle which avoids far-flung, unstable equilibria. But that too is not zero-sum. Some agents profit while others lose, while still others break even. That is not zero-sum. The long-term overarching effect of the market, regardless of boom-bust, has always been to increase the amount of resources, both human, natural, technological, etc., in the system, providing the metastable equilibria within the market landscape for such innovation and expansion, which is why capitalist market economies always increase overall wealth, including for the poorest participants. Applied to nation-states, this type of system, nations as the agents, and profit counted more liberally by various complex measures like happiness factor, food, health, economy, rights, etc., are still the goal of profit for each agent. But this does not lead to conflict that is zero-sum in nature. Rather, it leads to complex dynamical behavior, resulting in a metastable global international relational semi-equilibrium. And that global international semi-equilibrium is what frankly allows the global capitalist market to function as it does. Centralizing control, unifying agents into larger and larger agents in smaller and smaller numbers, only reduces the complexity of the system to the point where zero-sum becomes the only option, and we end up in a communist or fascist tyranny. In short, it is a larger number of smaller agents rather than some overarching centralized control or oligarchic order of a few large agents, which creates the metastable semi-equilibrium about the local optima, which create a complex semi-ordered system that allows for innovation due to increasing agentic freedom, i.e. the number of choices for each agent, and of course the number of agents. This is true in markets where centralization only multiplies problems. And at a larger scale, which includes markets as one of the primary fitness landscapes in the multidimensional fitness landscape, the international order is more stable against large perturbation or extremes such as global war when there are a larger number of smaller agents, like nation-states, contributing to the complexity of the system by following their own profit motivation as defined: happiness of citizens, education, healthcare, economy, liberty, as can be measured and agreed as valued by the agentic nation-state. This is what Alexander Wissner-Gross terms maximizing future entropy, as an information theoretic definition of axiomatic intelligence. This comes from the area of complex adaptive systems theory regarding artificial intelligence and intelligent systems. It is the most fundamental axiomatic definition yet contrived for minimal intelligent systems. Link in the description. So, the capitalist market, biological evolution of species, and the international semi-order approach an intelligent system and at least surpass the Wissner-Gross Criterion for a minimal intelligent system. These systems do display intelligent emergent behavior, finding more optimal solutions over time. Evolution, for example. I mentioned The Origins of Order by Stuart Kauffman, 1993. And further evolving toward higher adaptability. That is, via evolutionary adaptation, via complex responses to the changing fitness landscape, the system adapts, and also adapts in order to adapt faster and better over time. It adapts to adapt better. And that is why totalitarian states and totalitarian centralization of economies always fail. Such emergent evolutionary behavior with increasing adaptability only occurs in complex adaptive systems, which centralization destroys. And as I previously pointed out, the international order, as it were, is more stable against large perturbation or extremes, such as global war, when there are a large number of smaller agents, i.e. nation-states, contributing to the complexity of the system by following their own profit motivation as previously defined. Complexity is further increased when at least some decisions are primarily made by many agents within the nation-state, as occurs in democracies. Democratic, representative, and republican practices inject even more complexity into the system, computational complexity as well as the number of choices for each agent, maximizing future entropy, as defined by Wissner-Gross. As we can see, the world, including biology, is ordered by complex adaptive systems on top of and within complex adaptive systems. Totalitarianism, centralization, curtailing of individual rights, reducing the number of choices for each agent, all add up to a reduction in system complexity, or future Shannon entropy, below the Wissner-Gross threshold for minimal intelligence. And that's why totalitarianism and centralization of decisions always fails. And capitalist markets within a large ensemble of sovereign nation states succeed in evolving faster, adapting better, and which has produced the greatest prosperity for the greatest number of people in human history.